We are going to solve this system of equations by using an augmented matrix. So the way we do that is this, that we can create a matrix, and the matrix that we are creating is this, and you can see the first column is formed by taking the coefficients of x in this system, second by taking the coefficients of y, and the third column by taking the values on the right hand side of the equation. So in a way, we have just augmented this matrix made up with the coefficients by these values, and often it is also called augmented matrix of this system. Okay, so this is an augmented matrix for this system here. And as I have written in the notes for you, that here it may look like that we are making a simple procedure very complicated, but later on, when you have many linear equations and many unknowns, this will come out to be pretty handy. Okay, so our strategy will be to use a combination of valid row operations to transform this augmented matrix to a matrix of this form, which is also called row reduced echelon form of the augmented matrix that we have. And if we are successful in doing that, then what would happen is this will be the value of x, and this is going to be the value of y. If we are not, we are going to discuss those situations later. Okay. Now the row operations that we can use are, we can interchange any two rows, or we can multiply a row by a non-zero number and add multiple of a row to another row, as you are going to see in the example that we are taking up. So this is our augmented matrix. Okay, let me just make the line here just formally. Okay, and if possible, one of good strategies is that take up the first element of the first column and transform it to 1. That is, we would like to have a 1 in place of 3. And these are the operations that we are allowed. So if we look at it, we cannot interchange these two because this is not a 1. So that doesn't work. We can use this because we can multiply a row by a non-zero number. So multiplying the first row by 1/3 will do the job, but that's going to give us fractions, and nothing wrong with fractions, but let's see if we can avoid them. So we can see this, that is, so we are discarding it for the moment. If we look at this option here, that is add multiple of a row to another row, so we can subtract this second row from this first row. Now it looks strange that I said subtract and here we have add, but subtracting the second row from the first row amounts to the same thing as adding -1 times the row number 2 to row number 1. Okay, so let's see what we mean. So what we are going to do is that we are going to add -1 times this second row to row number 1. So this is your row 1, and excuse me, and this is a multiple, that is -1, multiple of -1 with R2. We are adding these two together. So what we have is the following, that so this is again row number 1 as it is, right? and then this is negative 1 times row number 2, and if we add them together, what are we going to get? Here we have simply 3 plus negative 2, or 3 minus 2 is 1, 2 minus 3 is negative 1, and 1 plus 1 is 2. So what we are going to do now, we are going to let this take place of this first row in the augmented matrix. That is, this row will be changed by this transformed row now. So now we have a 1 here. Now our next strategy is, we are still in column 1, that we would like to transform this, or we would like a 0 here by using combination of these 3 operations. Now you can see interchanging is not going to help. We cannot multiply 2 by a non-zero number and get a 0. So this is our only option left at this moment. So notice this, what we can do is, we can multiply this by negative 2, which is multiple of a row, and add it to the second row. So negative 2 times 1 will be negative 2, and plus 2 will give us a 0 here. So let's see. So our strategy is to add negative 2 times row number 1 to row 2, or in excuse me, in simple words, just subtract 2 times row number 1 from row number 2. That is, this is what we are getting at, right? Okay, let me place it a little to this side. So when we perform that operation, we get that. Okay. And when we add this, what we will have, we shall have, let's add them together. So negative 2 plus 2 will be 0, 3 plus 2 will be 5, negative 1 minus 4, when they are added up together, they will give us negative 5. So what we are going to do at this stage is that we will now replace this second row by who? By this by these transformed values. Pardon my English here. So now our first column is in the desired form. So next strategy is, take the second place in the second column, okay, and transform it to 1 if possible. Now if we look at these two, of course we cannot interchange the 2 rows because that's going to mess up our column 1, and this is a negative, so you know that's not possible. But here this is coming in pretty handy. That is, I have a 5 here, and this is also a multiple of 5. So we can multiply the row 2 by what? 1 over 5, right? Okay, so if we do that, this will be a 5. 5 times 1 over 5 is 5, and this will be what? This will be negative 1, and that is going to give us our transformation. This right here, multiply the second row by 1 over 5, and this is what you get. Now we are almost there. The first column is in the desired form, and here I have a 1. Now our next strategy is what? To obtain a 0 here. Okay, so how do we obtain a 0 here? Of course, interchange is not going to help. This is not going to give us a 0. Now notice this. If I add this row with the second row, what I'm going to get? 1 plus 0 is 1. Negative 1 plus 1 will give me a 0. And 2 minus 1 will give me a 1. So what do we obtain when we use that transformation? So what we have here in this matrix, when we added the row number 2 with row number 1, what we got? We got 1 plus 0 is 1, negative 1 plus 1 is 0, and 2 minus 1 is 1. So now we have the matrix in reduced form. Pardon me please. Okay, so we have our matrix in the reduced form, and these, excuse me, so sorry about that hiccup at that time. So what we have is this column corresponds to x, this corresponds to y. So what will this give us? X equals 1 and y equals -1, or in other words, what is the solution of the system that we were given to solve? X equals 1 and y equals -1. Now here we have a unique solution, and I'm going to post notes for you to see that what we do when we don't have a unique solution, sometime we will not have any solution whatsoever. Okay, so check the notes and post the questions for me if you have any, and you should have some questions. Thank you.